This is a tutorial on the pH case branch additional data tab in WUFI Passive. In a new WUFI Passive blank file, on the pH case branch additional data tab, a new file will show up with many of the entries already filled in. Typically, it is okay to keep these entries as they are default entries. You can go through and check one by one to ensure that they are defaults, or you may revise as appropriate if that is possible for that particular entry. Some of these are locked in for PHIUS Plus 2015 certification protocol. When filling out a WUFI Passive file, especially for the first time, I highly recommend following the certification guidebook. So in the certification guidebook, section 6 here is the energy modeling protocols. You'll see there's different information about how you get started, but then after that it follows the exact branch structure of WUFI Passive. So here we would be in Passive House case, so page 46, and we would follow the different parameters here. There's information about all of these different cells. So rather than walking through that, I will talk through that. So starting at the very top, there's the preferred minimum indoor temperature for night ventilation. In WUFI, under the ventilation room, summer ventilation tab, there is an entry for night ventilation, night flush, through either window opening or an automatic ventilation system for night flush. This minimum indoor air temperature will determine how cold it can get inside with that night flush. So you can keep 68. It's a recommended value here. So we'll move on. Overheating temperature threshold. This is your cooling set point temperature. For PHIUS Plus 2015, this is 77 degrees regardless of the project. That's just the certification protocol. So again, these were already filled in. Just moving on. The fresh air per person is the fresh air requirement per person for a residential project for PHIUS certification. So this is the ventilation air supply that you need per occupant of the building. This varies for residences versus schools versus some sort of commercial building. So again, 18 is the default for residential, so we will keep it at 18, but it may vary for other building types. Moving down, the hot water tap openings per person per day. The default for PHIUS certification is 3 for residential buildings. This can vary quite significantly for commercial buildings. Essentially, in WUFI Passive later on, you will enter the total length of the hot water pipe runs. What this assumes is that that total length of pipe goes to each of the individual hot water taps, and that each person occupying this space or living in this space in this case opens each one of those taps 3 times per day, and the hot water will run from the tank or from the storage to the individual tap, and there will be losses associated with that. There are 3 of these runs assumed right now per person per day at each tap. Again, that's the default for residential. Again, this may change significantly for commercial if there's, say, 100 people and maybe a portion of them use the hot water. Definitely not 3 times each. Depending if it's a store versus if it's an office, this may vary. Hot water tap opening utilization days per year. For residential, this should be the entire year, 365 if people are occupying the building the entire year. If it's something like an office, maybe it's 250 days. It could be lower if it is not a residential building. Moving down, the air tightness metric. This is the envelope air tightness at 50 pascals. That is PHIUS's requirement, or the PHIUS's limit is based in CFM 50 per foot squared of envelope area. So that is the metric we're looking at here. And the entry below it shows the envelope air tightness at 50 pascals. And we will always, or I would recommend always for pre-certification or for initial modeling at the highest limit for PHIUS Plus 2015, which at this point is 0.05 CFM per foot squared of envelope area at 50 pascals. You can always aim for a lower air tightness, but modeling up front with the 0.05 is usually the safest. Next, moving down, you get to select the type of ventilation system. Almost always this is balanced ventilation, so keep moving here. The maximum humidity ratio, determines how high or what level of humidity you will allow in the interior space before dehumidification is needed. So this will determine how much of the cooling or how much dehumidification demand you will have over the course of the year, depending on what this limit is. So if this limit was lower, let's say 0.01 instead of 0.012, then there would be more need for dehumidification. If it was higher, 0.015, then there would be less need for dehumidification. If you'd like to determine that based on the air temperature and dew point, you can enter these separately. If you want to allow up to a dew point of 55 with an air temperature of, let's say actually 60 with an air temperature of 77 inside, you can change that there. And now it's revised my humidity ratio. So you can either use the default of 0.012 or you can revise appropriately for what you would like for the project. It cannot be higher than 0.012, but it can be lower if you feel that more dehumidification is appropriate. Moving down, you need to define how exposed the building is to wind pressure. Up here we have entered envelope air tightness at 50 pascals, so at a certain pressure there's a certain amount of envelope leakage. Now we need to determine or estimate what the natural pressure on the building will be based on how exposed it is to wind. So there's options here, predefined options. Typical buildings, there's several sides exposed, and there's either no screening, moderate screening, or high screening. This just depends on your surroundings. And then say you potentially are modeling a single unit within a building, or something, a row home, a town home that has only one, maybe a front and back side exposed. You could use the one side exposed with no screening, moderate screening, or high screening, or you can always use user defined. So if you think it's somewhere between moderate and high screening, you could select these, which change the wind screening coefficient, wind exposure factor, wind shield factor. Note what this might be for moderate screening, note what they are for high screening, and then select user defined and enter something in between those two. Typically the default is several sides exposed and moderate screening. In WUFI Passive there are also sections of optional data at the bottom, and it will tell you that if you do not define the value, default values will be used. So technically we could use these values, or we could leave these values blank. Most of the time WUFI Passive does not like blank cells. You will get errors. You will not get final results until you fill them in, except for the areas where there are optional data entries. So here we can leave these blank. However, we can also enter default values. So hot water consumption per person per day at 140 degrees. As shown in my hover over hint here, the default is 6.6 gallons per person per day. So again, if I did not enter 6.6, it would assume 6.6. So I can enter something higher, potentially, if I believe the value is higher, or I can leave it blank. The average cold water temperature of the supply, moving below, this is defined for how cold the hot water supply is coming in, which determines how much energy do I need to put into the water to bring it up to the use temperature, which in this case is 140 degrees. If I leave this cell blank, then it will use my average annual ground temperature, so I'd recommend doing that, or you can use the default value of 50 degrees. And lastly, the mechanical room temperature. This is used to determine the amount of losses from something such as a hot water storage tank. You'll define the losses in BTU per hour per degree Fahrenheit. So the temperature of the mechanical room, or the temperature of the space where the storage room is where the storage tank is, will determine the amount of losses from the tank. So if it's inside, you can keep 68 degrees. If it is in some sort of semi-conditioned space or an unconditioned basement, you should use the average ambient temperature. So you can determine that by going into your climate data and averaging the 12 months of the year, determining the average ambient temperature and entering it here. If you leave this blank, it will use 68 degrees. In a filled out project, under additional data, you will see down here at the very bottom, when there are results, that there's different air dehumidification potential calculated based on the maximum humidity ratio that you've defined here. So I use 0.012, the PHIUS default, and it's showing that none of these different months will the humidity ratio be above that. However, if I made it more stringent, 0.009, then it's showing the potential dehumidification in June, July, and August is present.